The constellation of Orion is one of the most recognizable patterns in the night sky, a celestial hunter marching across the winter heavens. Its right shoulder is marked by a brilliant, reddish star, one of the brightest we can see. This star is Betelgeuse, and recently, it has been acting very strangely. For centuries, astronomers have known Betelgeuse as a variable star, meaning its brightness fluctuates over time. But in late 2019 and early 2020, it did something unprecedented in modern history. It dimmed dramatically, losing more than two-thirds of its usual luminosity in an event that astronomers dubbed the Great Dimming. This sudden and mysterious fading sparked a wave of excitement and speculation. Was this the final curtain call for a stellar titan? Was Betelgeuse about to explode? The idea is tantalizing because Betelgeuse is not just any star. It's a red supergiant, a star in the final, dramatic phase of its life. Stars like our Sun live relatively quiet lives for billions of years, but massive stars go out with a bang. Betelgeuse is colossal, estimated to be about 15 to 20 times the mass of our Sun. If you were to place it at the center of our solar system, its surface would extend out past the orbit of Mars, and possibly even Jupiter. It is a star living on borrowed time. The life of a star is a constant battle between two opposing forces. The first is gravity, the immense force of the star's own mass trying to crush it inwards into an infinitesimally small point. The second force is the outward pressure generated by nuclear fusion in its core. For most of its life, a star like Betelgeuse fuses hydrogen into helium, releasing a tremendous amount of energy that pushes against gravity's relentless pull. This delicate balance is what keeps a star stable. But this process cannot last forever. Eventually, the hydrogen fuel in the core runs out. For a massive star like Betelgeuse, this is where things get really interesting. Gravity begins to win, compressing the core and heating it to even more extreme temperatures. This new heat and pressure ignite the fusion of helium into heavier elements like carbon and oxygen. The star gets a new lease on life, but it's a turbulent one. This new fusion process is less efficient and much more violent, causing the star's outer layers to swell up enormously. The star expands, cools at its surface, and takes on a reddish hue. It becomes a red supergiant, a bloated and unstable behemoth. Betelgeuse is currently in this phase of its life. Inside its core, the star continues to forge heavier and heavier elements. After helium is exhausted, carbon begins to fuse, then neon, then oxygen, and then silicon. Each stage of fusion happens faster and faster, a frantic race against the inevitable gravitational collapse. The final stage is the fusion of silicon into iron. And this is the end of the line. Fusing iron does not release energy, it consumes it. The outward pressure from fusion that has supported the star for millions of years suddenly vanishes. In an instant, gravity wins the long war. The star's core collapses in on itself in a fraction of a second, rebounding off a superdense neutron core. This catastrophic rebound sends a shockwave rocketing outwards through the star's layers. This is a supernova, one of the most powerful explosions in the universe. The shockwave tears the star apart, blasting its outer layers into space at a fraction of the speed of light. For a brief period, a single supernova can outshine its entire galaxy. This is the spectacular fate that awaits Betelgeuse. The only question is, when? Astronomically speaking, soon could mean tonight, or it could mean 100,000 years from now. The Great Dimming of 2019 made many wonder if the time was finally at hand. If Betelgeuse were to go supernova, its proximity to us, at about 650 light-years away, would make it an unparalleled celestial event. From our perspective on Earth, it would be a breathtaking spectacle. Betelgeuse would suddenly become incredibly bright, easily visible during the daytime. For several weeks, or even months, it would shine as brightly as the full moon, casting faint shadows at night. It would be a second moon in our sky, a brilliant, temporary beacon that would change the night for everyone on Earth. Generations of humans have looked up at Orion, but we might be the generation to see it forever changed. The hunter would lose his shoulder, replaced by a radiant new star that slowly fades into a beautiful, expanding nebula. But would this spectacular light show pose any danger to us? A supernova is an incredibly violent event, releasing vast amounts of energy and radiation. Fortunately, at a distance of 650 light-years, we are well outside the kill zone. The most dangerous radiation, like gamma rays and X-rays, would be significantly diluted by the vast expanse of space before reaching us. The main effect would be on our upper atmosphere. A nearby supernova would bombard Earth with high-energy particles and radiation, which could potentially damage the ozone layer. The ozone layer is our planet's natural shield against harmful ultraviolet radiation from the sun. Studies suggest that a supernova at Betelgeuse's distance might deplete the ozone layer by a few percent. This would lead to a slight increase in UV radiation reaching the surface, but it would not be a catastrophic, life-ending event. The effects would be measurable but likely not devastating for life as a whole. It's a far cry from the planet-sterilizing blast that would occur if the supernova were much closer, say within 50 light-years. So, what actually caused the Great Dimming? Was it a sign of the impending explosion? After intense observation with instruments like the Hubble Space Telescope, astronomers pieced together a compelling explanation. It seems the dimming wasn't a sign of the core's imminent collapse, but rather a surface-level event. The leading theory is that Betelgeuse experienced a massive convective plume, like a giant bubble of hot gas rising from its interior to the surface. This event was so powerful that it ejected a huge cloud of stellar material into space. As this cloud of gas moved away from the star, it cooled and condensed into a vast shroud of dust. This dust cloud then drifted in front of Betelgeuse from our point of view, blocking a significant portion of its light and causing the dramatic dimming we observed. Essentially, the star sneezed, and we happened to be in the path of the resulting dust cloud. By mid-2020, Betelgeuse had returned to its normal brightness, as the dust cloud had moved on, dissipating into interstellar space. This event was a reminder of just how dynamic and chaotic the surface of a red supergiant is. These stars are constantly churning and shedding mass, their surfaces roiling with convection cells the size of our entire solar system. While the Great Dimming probably wasn't the final death throw, it gave us an unprecedented look at the processes that happen on a star just before it goes supernova. The material shed by these stars enriches the galaxy with heavy elements. The very elements that make up our planet, and even our bodies, were forged in the hearts of stars and scattered across space by supernova explosions. The carbon in our cells, the oxygen we breathe, the iron in our blood, it's all stardust. Betelgeuse is a ticking clock. It will explode. We just don't know the exact time. The neutrino detectors here on Earth are constantly watching. When the core collapses, it will release a massive burst of these ghostly particles, which travel at nearly the speed of light. This neutrino burst will reach Earth hours before the light from the explosion does, giving us a final, definitive warning. When that signal arrives, every telescope on and off the planet will turn to watch the show of a lifetime. Until then, we continue to watch and learn from this fascinating, aging giant. Each flicker and fade gives us new clues about the final moments of the most massive stars in the universe. And as you look up at the constellation of Orion, take a moment to appreciate that brilliant, reddish star. You might just be witnessing the calm before the cosmic storm. Thank you for joining me on this journey into the heart of a dying star. If you enjoyed this exploration of the cosmos, be sure to subscribe to Space Repo for more deep dives into the wonders of our universe.